Explorer 1, America's Renaissance in Space. Imagine, October 4th, 1957, a strange beep-beep sound echoes through the night sky. The world stood still. The Soviet Union had launched the world's first artificial satellite into space, Sputnik 1. For America, it was a massive shock. Shame at falling behind in space research and fears for national security spread everywhere. Just 1 month later, the Soviets sent up Sputnik 2, carrying the dog Laika. In the race to conquer space, America was only preparing to take its first steps. But fate had other plans. On December 6, 1957, tension was sky high. America's first attempt, the Vanguard TV3, Test Vehicle 3 rocket, was supposed to soar proudly into the sky. But just a few seconds after liftoff, a tremendous explosion shattered it into pieces. The whole world laughed. Newspapers ran headlines like "Flopnik." But behind the scenes, in the laboratories, a secret weapon was being built. Not some gigantic rocket, but a pencil-thin satellite that would change forever how we view the universe. It was born as Explorer 1, America's first satellite. Following the failure of Vanguard, the Eisenhower administration swiftly took action. The task was given to the Army Ballistic Missile Agency, ABMA, and the Jet Propulsion Laboratory at the California Institute of Technology. 3 prominent leaders headed the effort. Wernher von Braun, the German rocket scientist who developed the Jupiter-C rocket. William Pickering, director of the Jet Propulsion Laboratory, JPL. And James Van Allen, physicist from the University of Iowa, who designed the satellite's main scientific instrument. They were given just 90 days to complete the project, but remarkably, they finished in only 84 days. This was a crucial effort to restore the nation's pride. Explorer 1 was a compact device, much smaller than modern satellites. Measuring 203 centimeters, or 80 inches in length, and 15.2 centimeters, or 6 inches in diameter, it weighed only 13.97 kilograms, or 30.8 pounds. In comparison, the Soviet Sputnik 1 weighed 83.6 kilograms. The Americans' goal was to create a small yet highly effective satellite. America's first artificial satellite, Explorer 1, represented an extraordinary engineering achievement. Its design and operation were meticulously planned, marking a new chapter in the history of space exploration. To maintain stability in orbit, the satellite spun around its long axis at a rate of about 750 times per minute, using spin stabilization for balance. To manage temperature effectively, its exterior was made from sandblasted stainless steel with white stripes. This design helped protect the internal components from excessive heat by utilizing the temperature difference between sunlight and shadow. Explorer 1 was one of the earliest spacecraft to incorporate transistors in its electronics, featuring a total of 20 germanium and silicon transistors, cutting-edge technology for its time. The power source consisted of mercury chemical batteries, which contributed approximately 40% of the satellite's total weight. Under the guidance of Dr. James Van Allen, 3 primary scientific instruments were installed on Explorer 1. A cosmic ray detector, utilizing an Anton 314 Geiger-Müller tube to detect cosmic rays. 5 resistance thermometers to measure temperature, providing data on both internal and external environments. An acoustic detector and a wire grid detector to identify micrometeorites, or tiny dust particles in space. Explorer 1 was launched using a 4-stage rocket known as Juno 1, also referred to as Jupiter-C in its earlier form. Wernher von Braun developed this rocket. The Juno 1 was created by the Army Ballistic Missile Agency, ABMA, with construction led by Chrysler Corporation. Its design was based on the Jupiter-C test rocket, which was originally a three-stage vehicle used for re-entry testing. A small modification added an extra stage to enable satellite launches. The Juno 1 stood approximately 21.2 meters, or 70 feet, tall, had a diameter of 1.78 meters, or 5 feet 10 inches, and weighed around 29,060 kilograms. Cape Canaveral, Florida, January 31, 1958, 10:47 p.m. Eastern Time. The countdown began. Mounted atop the Juno 1 rocket, Explorer 1 spread its wings into the sky. But the anxiety wasn't over yet. Even 90 minutes after launch, there was no confirmation that the satellite had reached orbit. No signal was received from the Goldstone tracking station in California. Why? The satellite had climbed much higher than expected. Finally, at 12:30 a.m., the news arrived. America had succeeded. In Washington, at a press conference, Pickering, Van Allen, and von Braun held a replica of Explorer 1 above their heads. That photo remains immortal in history. It orbited the Earth every 114.8 minutes. Its perigee, or lowest point, was 358 kilometers, and apogee, or highest point, was 2,550 kilometers. Explorer 1 didn't just orbit the Earth, it made a groundbreaking discovery that changed scientists' understanding of space forever. Data from its Geiger counter revealed unexpected results. Typically, the counter recorded about 30 cosmic rays per second, but at altitudes above 2,000 kilometers, it suddenly reported 0 counts. James Van Allen realized that the instrument wasn't malfunctioning. Instead, the radiation was so intense that it overloaded the device. This observation led to the discovery of vast belts of charged particles trapped in the Earth's magnetic field, now known as the Van Allen radiation belts. This finding is considered one of the greatest achievements of the International Geophysical Year. Explorer 1's mission was brief. Its high-powered transmitter operated for 31 days, while the low-powered transmitter functioned for 105 days. On May 23, 1958, the batteries were completely depleted and data transmission ceased. However, the satellite continued to orbit for much longer. Finally, over 12 years after its launch, on March 31, 1970, it re-entered Earth's atmosphere and burned up over the Pacific Ocean. By that time, it had completed 58,402 orbits around the Earth. An unusual scientific phenomenon occurred during the mission. After launch, the satellite began to precess, which means it was rotating around a different axis than intended. This puzzled scientists and led to renewed research into rigid body dynamics and Euler's theory. The energy dissipation caused by this behavior contributed to the design of future space missions. Explorer 1 wasn't just a small satellite. It represented America's resurgence in space exploration. It demonstrated how to learn from failure and turn the seemingly impossible into reality in just 84 days. The groundwork for the GPS technology we rely on today, along with our aspirations for space travel, was established that night in 1958. In today's world of large satellites, this 13-kilogram device may seem insignificant, but its historical importance is immeasurable.